This is a video from eSkillZone. For more videos, notes, and certificate, please visit www.eskillzone.com.
Computer access control. In computer security, general access control includes identification, authorization, authentication, access approval, and audit. A more narrow definition of access control would cover only access approval, whereby the system makes a decision to grant or reject an access request from an already authenticated subject based on what the subject is authorized to access. Authentication and access control are often combined into a single operation, so that access is approved based on successful authentication or based on an anonymous access token. Authentication methods and tokens include passwords, biometric scans, physical keys, electronic keys, and devices, hidden paths, social barriers, and monitoring by humans and automated systems. Software entities. In any access control model, the entities that can perform actions on the system are called subjects, and the entities representing resources to which access may need to be controlled are called objects. Subjects and objects should both be considered as software entities rather than as human users. Any human users can only have an effect on the system via the software entities that they control. Although some systems equate subjects with user IDs so that all processes started by a user, by default, have the same authority, this level of control is not fine-grained enough to satisfy the principle of least privilege and arguably is responsible for the prevalence of malware in such systems. In some models, for example, the object capability model, any software entity can potentially act as both subject and object. As of 2014, access control models tend to fall into one of two classes: those based on capabilities and those based on access control lists, ACLs. In a capability-based model, holding an unforgeable reference or capability to an object that provides access to the object, access is conveyed to another party by transmitting such a capability over a secure channel. In an ACL-based model, a subject's access to an object depends on whether its identity appears on a list associated with the object. Access is conveyed by editing the list. Different ACL systems have a variety of different conventions regarding who or what is responsible for editing the list and how it is edited. Both capability-based and ACL-based models have mechanisms to allow access rights to be granted to all members of a group of subjects. Often the group is itself modeled as a subject. Services. Access control systems provide the essential services of authorization, identification, and authentication, i.e., access approval, and accountability where Number 1. Authorization specifies what a subject can do. Number 2. Identification and authentication ensure that only legitimate subjects can log on to a system. Number 3. Access approval grants access during operations by association of users with the resources that they are allowed to access. Number 4. Accountability identifies what a subject did for all subjects associated with a user. Authorization. Authorization involves the act of defining access rights for subjects. An authorization policy specifies the operations that subjects are allowed to execute within a system. Most modern operating systems implement authorization policies as formal sets of permissions that are variations or extensions of three basic types of access. Number 1. Read R. The subject can 1. Read file contents. 2. List directory contents. Number 2. Write W. The subject can change the contents of a file or directory with the following tasks. 1. Add. 2. Update. 3. Delete. 4. Rename. Number 3. Execute X. If the file is a program, the subject can cause the program to be run. These rights and permissions are implemented differently in systems based on discretionary access control, DACs, and mandatory access control, NAC. Identification and authentication. Identification and authentication. IMA is the process of verifying that an identity is bound to the entity that makes an assertion or claim of identity. The INA process assumes that there was an initial validation of the identity, commonly called identity proofing. Various methods of identity proofing are available, ranging from in-person validation using government-issued identification to anonymous methods that allow the claimant to remain anonymous, but known to the system if they return. The method used for identity proofing and validation should provide an assurance level commensurate with the intended use of the identity within the system. Subsequently, the entity asserts an identity together with an authenticator as a means for validation. The only requirements for the identifier is that it must be unique within its security domain. Authenticators are commonly based on at least one of the following 4 factors. Number 1. Something you know, such as a password or a personal identification number, PIN. This assumes that only the owner of the account knows the password or PIN needed to access the account. Number 2. Something you have, such as a smart card or security token. This assumes that only the owner of the account has the necessary smart card or token needed to unlock the account. Number 3. Something you are, such as fingerprint, voice, retina, or iris characteristics. Number 4. Where you are, for example, inside or outside a company firewall, or proximity of login location to a personal GPS device. Access approval. Access approval is the function that actually grants or rejects access during operations. During access approval, the system compares the formal representation of the authorization policy with the access request to determine whether the request shall be granted or rejected. Moreover, the access evaluation can be done online. Accountability. Accountability uses such system components as audit trails, records, and logs to associate a subject with its actions. The information recorded should be sufficient to map the subject to a controlling user. Audit trails and logs are important for: Number 1. Detecting security violations. Number 2. Recreating security incidents. If no one is regularly reviewing your logs and they are not maintained in a secure and consistent manner, they may not be admissible as evidence. Many systems can generate automated reports based on certain predefined criteria or thresholds, known as clipping levels. For example, a clipping level may be set to generate a report for the following: Number 1. More than 3 failed logon attempts in a given period. Number 2. Any attempt to use a disabled user account. These reports help a system administrator or security administrator to more easily identify possible break-in attempts. Definition of clipping level. A disk's ability to maintain its magnetic properties and hold its content. A high-quality level range is 65 to 70%. Low quality is below 55%. Access controls. Access control models are sometimes categorized as either discretionary or non-discretionary. The three most widely recognized models are discretionary access control, DAC, mandatory access control, MAC, and role-based access control, RBAC. MAC is non-discretionary. Discretionary access control. Discretionary access control, DAC, is a policy determined by the owner of an object. The owner decides who is allowed to access the object and what privileges they have. Two important concepts in DAC are: Number 1, file and data ownership. Every object in the system has an owner. In most DAC systems, each object's initial owner is the subject that caused it to be created. The access policy for an object is determined by its owner. Number 2, access rights and permissions. These are the controls that an owner can assign to other subjects for specific resources. Access controls may be discretionary in ACL-based or capability-based access control systems. Mandatory access control. Mandatory access control refers to allowing access to a resource if and only if rules exist that allow a given user to access the resource. It is difficult to manage, but its use is usually justified when used to protect highly sensitive information. Examples include certain government and military information. Management is often simplified over what is required. If the information can be protected using hierarchical access control or by implementing sensitivity labels. What makes the method mandatory is the use of either rules or sensitivity labels. Sensitivity labels. In such a system, subjects and objects must have labels assigned to them. A subject's sensitivity label specifies its level of trust. An object's sensitivity label specifies the level of trust required for access. In order to access a given object, the subject must have a sensitivity level equal to or higher than the requested object. Data import and export. Controlling the import of information from other systems and export to other systems, including printer, is a critical function of these systems, which must ensure that sensitivity labels are properly maintained and implemented so that sensitive information is appropriately protected at all times.
This is a video from eSkillZone. For more videos, notes, and certificate, please visit www.eskillzone.com.